active site is covered by the troponin-tropomyosin complex. Okay, so let's draw the troponin-tropomyosin complex. Okay, the troponin-tropomyosin complex covers the active site when the muscle is not contracting, when the muscle is at rest. Okay? Now, when the nerve impulse strikes the myofilament, myofibrils, the sarcoplasmic reticulum will release calcium ions. The calcium ions will remove the troponin-tropomyosin away from the active site. Okay. Yes. It removes the troponin-tropomyosin complex away from the active site. And it leaves the active site exposed. All right, so the calcium ion has removed the troponin-tropomyosin complex. All right? Now, the thick myofilament has a head and tail, okay? So here we have a tail and a head. When the active site is left exposed, the head of the myosin will attach to the active site immediately. Okay? And we call that cross-bridging. Now, everyone look at me. Please note that the head and the tail of the myosin will always face the Z lines, and when they attach to the active site, they will pivot toward the M line. Okay? And the second step will be pivot. And when they pivot toward the midline, they pull the thin myofilaments toward the midline, okay? And that is called, what is that? Sliding filament. Now, that shortens the sarcomere, and the shortening of the sarcomere constitutes contraction. Right? Now, to end contraction, the head of the myosin will detach from the active site. And everything returns to their original position. The head of the myosin will now face the Z line again. The thin myofilaments will return to their original position. The calcium ions will return to the sarcoplasmic reticulum, and the troponin-tropomyosin will recover the active site. So everything returns to their original position, and that is return. Okay? So these are the 5 steps involved with contraction. All right, so let's review this again. The active site is on the thin myofilament, and it's covered by the troponin-tropomyosin complex when there is no activity, when the muscle is at rest. When the nerve impulse strikes the fibril, the calcium ions are released from the sarcoplasmic reticulum, and they will go to the active site and remove the tropin and tropomyosin away from the active site, leaving the active site exposed. Immediately upon the active site being exposed, the head of the myosin will attach to the active site, and we call that cross-bridging. And when the head of the myosin attaches to the active site, they will pivot toward the M line. And when they pivot toward the M line, they pull the thin myofilaments toward the M line, and that shortens the sarcomere, and we call that sliding filament. Sliding filament. Okay? Now that constitutes contraction itself. All right, once the contraction is over, the head of the myosin will detach from the active site. And when the head of the myosin detaches from the active site, everything returns to their original position. The head of the myosin will now face the Z lines. The thin myofilaments will return to their original position. The calcium ions will return to the sarcoplasmic reticulum, and the tropin and tropomyosin complex will recover the active site. Okay. Now, please note, steps 1, 2, 3, and 4 require energy in the form of ATP. 5 does not. 5 is passive. Yes?
You said when everything turns back to normal at the end of contraction, the thin myofilaments face the M line?
No. They return to their normal position, okay? They're only pulled toward the M line when